In this tutorial, we will see how to calculate simple exponential smoothing forecasts. Unlike moving averages, simple exponential smoothing is a true forecasting technique. Exponential smoothing consists of several related techniques, including simple exponential smoothing. Exponential smoothing is the most widely accepted of all the univariate forecasting techniques. Univariate forecasting techniques are those forecasting techniques that use only the historical demand to produce the forecast. Exponential smoothing is widely used in retail and, in fact, all forms of services. It is easy to use, easy to understand, and fairly easy to compute. In spite of that, it is surprisingly accurate. In fact, in the absence of strong information to the contrary, exponential smoothing is the best choice for most forecasts. The basic formula is shown on the slide. It says that the forecast for any period equals the forecast for the prior period plus alpha% of the quantity of the demand last period minus the forecast last period. Alpha is called the smoothing constant. It has a value between 0 and 1, although values between 0.10 and 0.20 are the most common. Since demand minus forecast for any period can be seen as the error in that period, the formula can be rewritten. The revised version is the forecast for any period equals the forecast for the prior period plus alpha% of the error in the prior period. Some textbooks use a second version of the exponential smoothing formula as shown on the slide. If this is not the version of the formula used in your textbook, you can skip this slide completely. The formula on the slide says that the forecast next period is equal to alpha times the demand this period plus 1 minus alpha times the forecast this period. This is mathematically equivalent to the first formula. The examples will be shown using both formulas. If you are not interested in seeing the mathematical derivation, feel free to skip the rest of this slide. T and T plus 1 are just time periods. So we first replace T plus 1 with T, which also requires us to replace the T's with T minus 1. Next, we take the 1 minus alpha in parentheses and multiply through. 1 times f sub t minus 1 gives us just f sub t minus 1. Alpha times f sub t minus 1 gives us alpha f sub t minus 1. Next, we rearrange terms, moving the f sub t minus 1 to the left and combining two terms that are multiplied times alpha inside of parentheses. Finally, we move the alpha outside the parentheses and we have the original formula. As I said before, this is just a demonstration. The examples will be worked using both formulas even though they give the same answer. Before we work the problems, I need to say a word about rounding. In the simple and weighted moving averages, I rounded the forecast to whole numbers. I was able to do that because each calculation was independent. That is, how I rounded one calculation in no way affected the results of the next calculation. With exponential smoothing, this is no longer the case. This is true for all the approaches we will look at for both simple and trend-adjusted exponential smoothing. The results of one calculation feed into the next. Those results feed into the next, and so on. Thus, rounding is cumulative. To avoid cumulative rounding errors, I recommend that you round your results to 2 decimal points, and that is what I will do in these videos. Nevertheless, let me point out that companies cannot produce fractional units. Thus, if you were showing your results to a manager rather than your professor, you would always want to show whole numbers even if you were carrying them out to 2 decimal points in your calculations. Since the forecast this period is based on the forecast last period, how do you get started? No matter what period you try to get started in, you need the prior forecast to get started. In other words, you need to seed the forecast. Textbooks use 3 approaches to seeding the forecast. 1. Just give you the value for the first forecast. This is the least common approach. 2. Make the forecast in period 1 equal to the demand in period 1 and begin the calculations in period 2. 3. Make the forecast in period 2 equal to the demand in period 1 and begin the calculations in period 3. While it may not appear so when you first hear them, methods 2 and 3 are mathematically equivalent. Since the first approach is so uncommon, we will use method 3 in this video. Using the data shown on the slide, produce a simple exponential forecast for as many periods as possible using an alpha value of 0.20. Using either version of the formula, we begin by copying the demand for period 1 down as the forecast for period 2. For period 3, F3 equals the prior forecast of 125 plus alpha of 0.20 times the difference of the demand last period of 130 and the forecast last period of 125. That works out to 126.00. For period 4, F4 equals 126 plus 0.20 times the difference between 141 and 126.00. That works out to 129.00. For period 5, F5 equals 129.00 plus 0.20 times the difference between 142 and 129.00. That works out to 131.60. For period 6, F6 equals 131.60 plus 0.20 times the difference between 150 and 131.60. That works out to 135.28. For period 7, F7 equals 135.28 plus 0.20 times the difference between 157 and 135.28. That works out to 139.62. For period 8, F8 equals 139.62 plus 0.20 times the difference between 157 and 139.62. That works out to 143.10. For period 9, F9 equals 143.10 plus 0.20 times the difference between 164 and 143.10. That works out to 147.28. For period 10, F10 equals 147.28 plus 0.20 times the difference between 164 and 147.28. That works out to 151.22. Finally, for period 11, F11 equals 151.22 plus 0.20 times the difference between 171 and 151.22. That works out to 155.18. Just like before, Method 2 begins with making the forecast in period 2 equal to the demand in period 1, or 125 in this case. For period 3, F3 equals the alpha value of 0.20 times the demand last period of 130. All this is plus 1 minus alpha, or 1 minus 0.20 equals 0.80 times the forecast from last period of 125.00. This equals 126.00. Note that since 1 minus alpha will remain 0.80, we will not recalculate it each time. For period 4, F4 equals the alpha value of 0.20 times the demand last period of 141 plus 0.80 times the forecast last period of 126. This all equals 129.00. For period 5, F5 equals 0.20 times 1.42 plus 0.80 times 129.00. This all equals 131.60. For period 6, F6 equals 0.20 times 150 plus 0.80 times 131.60. This all equals 135.28. For period 7, F7 equals 0.20 times 157 plus 0.80 times 135.28. This all equals 139.62. For period 8, F8 equals 0.20 times 157 plus 0.80 times 139.62. This all equals 143.10. For period 9, F9 equals 0.20 times 164 plus 0.80 times 143.10. This all equals 147.28. For period 10, F10 equals 0.20 times 167 plus 0.80 times 147.28. This all equals 151.22. Finally, for period 11, F11 equals 0.20 times 171 plus 0.80 times 151.22. This all equals 155.18. The slide on the chart shows the actual data in blue and the forecast in orange. In the second example, use the same data and produce a forecast for all periods for which it is possible using an alpha value of 0.40. Use the formula used in your textbook. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. Of course, you get the same answer either way. Using the first formula, F2 equals the demand in period 1 of 125. F3 equals 125 plus 0.40 times 130 minus 125.00 equals 127.00. F4 equals 127.00 plus 0.40 times 141 minus 127.00 equals 132.60. F5 equals 132.60 plus 0.40 times 142 minus 132.6 equals 136.36. F6 equals 136.36 plus 0.40 times 150 minus 136.36 equals 141.82. F7 equals 141.82 plus 0.40 times 157 minus 141.82 equals 147.89. F8 equals 147.89 plus 0.40 times 157 minus 147.89 equals 151.53. F9 equals 151.53 plus 0.40 times 164 minus 151.53 equals 156.52. F10 equals 156.52 plus 0.40 times 167 minus 156.52 equals 160.71. F11 equals 160.71 plus 0.40 times 171 minus 160.71 equals 164.83. Once again, F2 equals 125. This time, since alpha equals 0.40, 1 minus alpha equals 0.60. F3 equals 0.40 times 130 plus 0.60 times 125.00, which equals 127.00. F4 equals 0.40 times 141 plus 0.60 times 127.00, which equals 132.60. F5 equals 0.40 times 142 plus 0.60 times 132.60, which equals 136.36. F6 equals 0.40 times 150 plus 0.60 times 136.36, which equals 141.82. F7 equals 0.40 times 157 plus 0.60 times 141.82, which equals 147.89. F8 equals 0.40 times 157 plus 0.60 times 147.89, which equals 151.53. F9 equals 0.40 times 164 plus 0.60 times 151.53, which equals 156.52. F10 equals 0.40 times 167 plus 0.60 times 156.52, which equals 160.71. F11 equals 0.40 times 171 plus 0.60 times 160.71, which equals 164.83. The chart on the slide shows the actual data in blue and the forecast in orange. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.